Now, back to the bone of contention. How is China Neo different from Neuralink? Mind you, in my subsequent video, I will fully explain Neuralink because Elon Musk has dropped something very interesting about it recently. Just to give you an idea, Neuralink uses extremely thin electrode threads inserted directly into the brain tissue to enable the device collect more detailed signals from the neural activity in the brain. The information is sent to an external computer that will interpret and perform required intentions out of all the information it has gathered from the brain. So, a person with Neuralink chip could perform more complex tasks, like controlling a computer or even playing a game by just imagining it. Sounds like metric, right? But Neo took a different route. It has 8 electrons positioned outside the brain tissue over the dura mater. Now, just to break that down, the dura mater is the tough outer membrane between the inner bone of the skull and the meninges that surrounds and protects the brain and the spinal cord. Now, because of this, Neo is only able to collect less detailed information. This method also reduces the risk of damaging the brain from the slightest lack of precision. So every brain operation actually requires a high level of accuracy. So Neo was designed with less invasive and more focused medical system. And this is where the real engineering lessons begins. China's Neo reached commercial approval before Neuralink, not because it was more powerful. It may have reached approval earlier for 2 main reasons. First, it was designed to solve one clearly defined medical problem. Neo is not trying to read everything a person is thinking. It's only looking for specific intention. The narrow objective made the technology easier to evaluate and introduce to clinical care. The second reason is that it attempts to balance performance with invasiveness. Instead of pursuing the highest possible number of electrodes, the developer focused collecting enough reliable information to perform a specific clinical task, while avoiding deep penetration into the brain. In healthcare, the most advanced technology does not always win. The technology that wins is the one that finds the right balance between performance, safety, clinical benefit, regulation, and patient access. So far, at the time of this post, we have only had a relatively small number of implanted patients, and more evidence is still needed concerning long-term safety. Approval in China does not mean the device is immediately ready and available in every hospital, but the approval still represents an important turning point. Brain-computer interfaces are gradually moving away from science fiction into real medicine. The first major use may not be giving elder people superhuman abilities. It may be something much more meaningful, helping someone who has lost the ability to move regain control over small but essential parts of daily life, helping a stroke survivor to participate more actively in rehabilitation, or helping someone who can no longer speak use their brain signal to communicate with the people around them. So, would you allow computer chips to be implanted in your brain if it could help you regain the ability to move your hands or communicate with people around you? Let me know what you think in the comment section. This is Smart Care Way. Let's engineer the healthcare future together. I'll see you in the next one.